we'll have most of you back on the ship and we'll all be sailing right. Now, the quantum numbers. Yesterday, we talked about Bohr, and I told you that Bohr had some issues with his model, right? So there's a scientist by the name of Erwin Schrödinger.
Isn't that his first name?
Erwin is. I just can't remember if it's spelled with an E or an I. And I was too lazy to look it up.
German?
I think he's Austrian.
That's not what I'm talking about. I'm talking about Philip.
What about him?
Isn't that his first name?
I think it's Edwin.
Edwin.
All right. So Erwin Schrödinger said that electrons are found in orbitals. Now, this word is almost the same as what Bohr said yesterday, except, and I point this out only because Brooke has given me a hard time, that the spelling is different by 3 letters. It has an ALS on it. However, yesterday, an orbit was that flat ring. An orbital is a 3-dimensional area of probability. It is where we believe there is the more likely, or I was going to say the greatest chance of finding an electron. For example, if Zoe's mom came right now to pick her up to take her to the doctor, well, let's just say she did. They would find out she's in 3rd period. They would call room 29, ask for Zoe to go to the office. This is the greatest chance of probability of finding her is in room 29 because that's what she's scheduled to be. However, does she have to be in room 29 right now? No, guidance could have called her. She could be in the bathroom. She could be wandering the halls. She could be almost anywhere. But the greatest chance of finding her is in room 29. So when you think about the Bohr models, even if you think about, well, Ms. Wall said these rings are wrong based on what Bohr said. Well, yes, and we still teach Bohr models. However, the thing that makes these different is now instead of viewing them as rings that the electrons have to be on, now think of the rings as the greatest chance of finding them. So maybe the electrons are close to the rings, but maybe they're not exactly on the rings. They're in the vicinity of the rings. Where Bohr said they had to be on the rings and you couldn't move anywhere but from one ring to another ring, Schrödinger is saying that's just the greatest chance of finding them. So they're going to be in the ballpark of the ring, but they don't actually have to be on the ring. Does that make sense? Okay, that's an orbital. Everybody caught up with me? Brooke, you there? Okay.
So it's like not on the ring.
It doesn't necessarily, it could be on the ring, but it doesn't have to be on the ring. That's what makes it different. Now, the biggest thing that we need to talk about today that Schrödinger did is he wrote a mathematical equation. Who? Schrödinger. Okay, he wrote a mathematical equation describing where the electrons in an atom are located. Okay. He wrote a mathematical equation describing where the electrons in an atom are located. Now, we're not going to actually write this math equation on the board. It's very long. It would fill the board. It's got a lot of Greek letters in it. We are never, ever going to need to know this. None of you will probably ever need to know this unless you go into some kind of chemistry theory. So, out of this equation, okay, so out of the equation, come 4 quantum numbers. Okay? And what did I just tell you? These 4 quantum numbers are going to do. In the top in the green, what did I tell you they were going to do? Okay. They're going to describe the location, or you can think of it as the address of an electron. Okay? So these numbers we're going to talk about today are like the address for an electron. No. Universally accepted symbol for an electron. Several people did. Lying to everybody at lunch. You can drag it around the cafeteria, talk about how mean I am. Just do it after class is over.
I'm gonna start a petition.
Go right ahead.
This is not Miss Pendergrass's class.
Everybody caught up?
You petition not to.
All right. So, the 4 quantum numbers. The first one. Okay, I'm going to do them in order. You do not have to necessarily learn them in order. That part's really irrelevant. All right, so the first one is called the principal quantum number. Its symbol is N. Now, this one tells 2 things. Some of them only tell us 1 thing. This one tells 2 things. It tells the energy level and the size. Okay? Tells the energy level and the size. All right, so let's say that I say n equals 1. What does n equals 1 mean? If you see that, what are you supposed to be able to get out of that? Okay, that means that it's the first energy level. And we'll draw a picture of it in a second. All right, if I say n equals 3, what does that tell us?
It's the 3rd energy level.
It's the 3rd energy level. All right, if I say n equals 5, what is that? Okay, it's the 5th energy level. Questions about how it tells energy level? Now, how does it say anything to us about size? Well, that goes back to what Diego just said about the rings. So if I say n equals 1, and it's the first energy level, how many rings are you going to have? 1. Okay? So if it's n equals 3, and it's the 3rd energy level, how many rings are you going to have? And if it's n equals 5, how many rings are you going to have? I'm going to struggle to get that 5th one in there. All right, so my question is, can you tell which one's bigger based on the energy levels?
Yeah.
Yes. Okay, so, all right, so which one would be the biggest? Okay, you know this is the biggest. Why? Okay, it has more what? It has more rings. Okay, so it's the biggest, it has more rings, or you could have said more levels, like, I think that was Jackie's voice I heard. Okay, more rings or more energy levels. Either answer would have been fine. Everybody okay with how to tell size or the energy level? Okay, the first quantum number and the last quantum number are the easiest of the 4. Everybody okay with the first? I haven't lost anybody yet, have I? Okay. If I've lost you already, we're in deep doo-doo today.
Easy.
This one's okay, right?
Yeah.
Okay. So the second quantum number is called the orbital quantum number.
We have to know the name.
Yes. Put it this way. If I was feeling a quiz tomorrow, I would feel like the names, the symbols, and what they tell us. Those kinds of things would appeal to me if I was giving a quiz tomorrow. Hint, hint.
Can you say it one more time?
I'm not saying it again. All right, so what does the orbital quantum number tell us? This one tells the sublevel and the shape. Only the first two tell two things. Okay, the last two only tell one. So the orbital quantum number tells the sublevel and the shape.
What you got that little cursive L right there for?
Because it's not an L. It's like this. And if I write that, everybody always tells me it's a what? Yes. But it's not a capital L.
What is that?
It's a L. It's a lowercase cursive L. It's the symbol for orbital quantum number. It's a cursive L. Yeah, on the computer I can italicize it or something like that. I could use a different font, but it's a lowercase L.
The principal quantum number N, that's
The principal quantum number is N. Yes. Okay? Now, what are the names of the sublevels? We're going to start there. The sublevel are S, P, D, and F. Okay? Those are the names of the sublevels. S, P, D, and F. They're all lowercase. You also need to learn them in this order. These are the only ones that matter if you learn them in order. The sublevels have to be learned in order. Okay? S, P, D, F. Huh? Yeah, we write them as lowercase letters. We're going to use these to write electron configurations and things later in the week. Now, thinking about what we just did. Okay? If n equals 1, what did we know n equals 1 told us just a second ago? All right, first energy level. Now, we have to be able to translate first energy level into how many sublevels we have, and we have to name the sublevels. So, if we're in the first energy level, how do you think the energy levels translate into sublevels? Are they equal? Are they multiplied by 2? What do you think? They're the same. Okay? So, the number of the energy level equals the number of sublevels. Okay? The number of the energy level equals the number of sublevels. So, how many energy levels do we have here? We have one energy level. So we get how many sublevels? We get one sublevel. Is everybody okay on how we made that leap? Zoe, Lyric, stop talking.
Sorry.
All right, so we have one energy level, so that gives us one sublevel. Now, we have to name that sublevel. Okay? What is the name of that one sublevel? The first sublevel's name is S, so we name it S. Now, hold on. In front of the S, we need to put a number. A 1 because it's in what energy level? So we name it 1S. Any questions?
LS.
No.
Is.
If n equals 3, what energy level are we in? Okay, we're in the third energy level. All right, how many sublevels do I have?
3.
right, and if I have 3 sublevels, we need to write their names. So what are the names of the 3 sublevels I have? They have to be in order, yes, because there are 3 of them. I need 3 names. S, P, and D. Now, again, because I'm writing the names of all 3 of them, they're in what energy level? So what do I put in front of them? 3S, 3P, and 3D. Now, that usually leads people to the next question, which is usually what? There you go. All right, what happens when we get to something like n equals 5? Okay? No. Okay? We have 5 energy levels, which means we have how many sublevels? We have 5 sublevels. And so we need 5 names. However, on the periodic table, we only need enough sublevels for 4 names. So we only name the first 4. So we name them as 5S, 5P, 5D, 5F, and there is a 5th one. We just don't write its name. I have to even at this point Google to see what its name is because it's been almost 30 years since I knew its name. Okay? You don't use it, you lose it.
Yeah.
Yeah.
So there are names.
There are names for the other sublevels, yes. And we're not using them. No. There's not enough elements on the periodic table. Because there would be 5 sublevels. Okay? It's just going to be empty because we don't have elements on the periodic table that would need space in those rooms. It's sort of like going to the beach and you have this huge hotel, but there's a hurricane coming and you only have rooms that occupy 12 rooms. So all the rest of the rooms are what? They're just empty. So this is always going to be what? Empty. It's never going to need to be filled because we don't have elements on the periodic table that need them. Matter of fact, if I cruise back here for just a second, what's the biggest energy level we're probably going to see? 7. Okay? If you look at the value of N, whoops, I left out N, is 1 to 7. Okay? Now, it's possible to have 8 in the excited state. But right now, okay, if you look at the periodic table, the newest one we have is this one behind my desk. And they've named, this is period 7 here, okay? That whole row has been named. There's nothing that's not filled in. At some point, if they find any new elements or discover any new elements before I retire, I may have to change that to 1 to 8. But right now, there's no new elements being discovered on the periodic table, so we only use values of 1 through 7. Okay? So given that, we don't have any need to figure out or to look up the name of that. Now, the names of those, whoops, come from here. They come from the spectral lines off these things, off line spectrals.
So if we have to write that.
You would just name 5S, 5P, 5D, and 5F. You wouldn't name beyond the F. Okay? Yeah, you wouldn't name this one out here because it doesn't have one that you know. So you just would not do that. Okay? No, you wouldn't even have to put a question mark. Okay? All right. Everybody good? What?
That value of 1 minus 7.
I'm wrong now.
That's 1 through 7.
I know, but I just didn't feel like saying it. Do as was right.
That's up to you. Do you need to know it? Yes, you do need to know it, which is why I wrote it.
All right, let me write it.
You need to stop talking and pay attention.
I was writing it, and you changed it.
Mm-hmm.
Wait, no problem. See, Jackie wrote it.
Just cut it off.
And so we're gonna write it.
Because it's in the way, clearly. She just wants you to take it off.
Yeah.
I'm not sure how she expects you to live and function, but take it out of the way. You caught up over there?
See, she won't pay attention. You might as well just move it.
Okay. have them.
Fabulous. All right, so the P sublevel, the D sublevel, the F sublevel, they have shapes too, right? So we've learned how to find their names. Now we need to talk about their shapes. Now, because orbitals are three-dimensional, okay? I'm going to draw these with X, Y, and Z axes. Yeah, it's plural.
Yeah. Stars.
All right, so the F sublevel is going to be like that, and its shape is a sphere. All right, the P sublevel has the X, the Y, and the Z axes, and theirs are going to have different shapes on different axes. It's the same shape, it's just on different axes. And y'all know I'm not very good artiste. I don't draw very well. So it's supposed to be like a peanut, or you can draw it as almost like an infinity sign. Okay, and then fill it in.
How many does F have?
F has 7.
Oh.
D has 5. F has 7.
You tweet.
You're,
Oh, you drew them differently or my
I drew them on different axes.
Oh. See, I was just drawing stars for real.
I told you what it was.
All right, you might need to clean those up a little bit. Now, what's the difference between the way I drew this one, and this one?
They're all like.
They're turned on different axes, right? So this will be PX. This one's named PY. And this one's named, actually that one's PZ. I drew that one on the PZ axis. And this one's on PY's axis.
Oh my God.
This will be important when we get to the next quantum number. All right, so I labeled the sphere. What does P look like to you?
Peanut.
Okay, that's one of the names we use.
Sunglasses.
Sunglasses is a no. Peanut, we also say dumbbell,
Hourglass.
and we use 2 lobes a lot. Now, either of these two, I expect you to be able to draw, okay? S and P, you should be able to draw. Now, D, you do not have to be able to draw. Now, this one is often referred to as having 4 lobes. Most of those, 4 of the 5 have 4 lobes like that. And then one of them looks like a peanut with a skirt around it.
You got PXP.
What? You could have
All right.
said clover.
And then this one is a flower. And the only way you're going to get to see what that one looks like is to look it up online, because I cannot draw that one for any reason.
Why you
I do
got
not have the skill to do
Why do
it.
you got PX, PZ, and PY? Because they different.
Yes, they're on different axes. And the same would be true for D if I could draw those, but I just can't.
Zelo. What is a
So
zelo?
we just needed to put.
It's 2 lobes.
Oh.
So for D, is it on the?
It doesn't really matter where you put D, because all 4 of those would look the same, which is why I don't draw the rest of them, because I can't make those look right. What did you say, Derek?
You need SP.
S is just a singular one. You can draw X, Y, and Z up there, but it doesn't matter how you rotate that one. It's still just a ball drawn X, Y, and Z.
Can you look up what it looks like
You can. Just type in the F sublevel. Look it up. Yeah,
right now?
if you want to.
I bet.
Are we going to talk about this?
Not using my phone.
140.
Dang, that don't. I know. I'm so I was like, we're finna leave.
Now it's club day.
Yeah, we
140.
did.
Type in the F sublevel. Just type in F. The F and then sublevel. And it should come up. I don't think you have to type in anything more than F sublevel.
How would you? Okay.
Did it come up?
Yeah. I don't know free.
I mean, I would think if I took off my Wi-Fi, it would come up with F sublevel. F sublevel.
There you go.
So cute.
I draw that.
Yeah. How can I draw that? It looks like a bunch of balloons around an axis.
So just draw.
I can't draw that stuff.
Can I draw for you?
No, we're not spending all day drawing this. No, we're not. All right, is everybody caught up? All right, yeah, everybody got what they need. All right, now, here's the part where I usually lose people.
Wait, can you go back for a second?
Oh my.
You were saying it last minute.
Bruh.
Yeah.
What
you say?
That's not real.
All right,
You.
so
Oh, Miss Ross.
I am not waiting on you all day to finish writing. What do you need?
Why she gotta watch the video? We are the video, so you can hurry up.
Well, I know they when they watch music back to laughing.
Yeah.
I'd be sick. This was a star that she
Moving on. Now,
Hi guys, it's your girl Zoe. Link in the description
Miss
below.
Ross, you said the one you put
flower. All right,
This channel.
here's the part where we struggle. The sub-level is not, or I should say this, the quantum numbers are not called the quantum letters. They're called the quantum numbers. So we have to assign the sub-level a number, not just a letter. So,
Yes, like the S on the chips.
if I give you
They're all in? Alright, you perseverance, so that's great.
all right, here's an address for an electron. This is just an example to illustrate what we've done to this point, okay? And this is a lot of times where I lose people. I know. So, we've talked about what two quantum numbers?
One and,
Don't tell me one and two.
Principal, quantum.
Principal and orbitals. What did principal tell us? The energy level and the size. So, the energy level. So,
And the next one was,
all right, so this right here tells me the energy level. Okay, remember, this is the address of the electron. So that tells me the energy level is which energy level? Okay, 2. I'm in the second energy level. Okay, now, this is which quantum number? Don't tell me 2. What was the name? Now, remember a minute ago when I said if we had a quiz tomorrow, what were the things I said we had to know?
The
names, The symbols, and what they tell us. Coming in telling me 1, 2, 3, 4, it's not getting anywhere. Okay? So what was the name? Okay, orbital quantum number. And what does the orbital quantum number tell us? The sublevel and the shape. All right, so this is our sublevel. Now, you got to know which sublevel we're talking about. Now, Luke, what's your zip code? Okay, what's your zip code, Derek? I don't have any 9-5s in here. I got some 9-5s. Y'all know how we decide 292 and 295?
Where you live, the location.
Okay, by what? Do you know how it's decided?
No.
2 and 5?
Y'all trash for your address.
City or no, it's like
People, it's 85. Okay, 85. If you live on that side, you're a 5. If you're on this side, you're a 2. If you got a post office box, it's a what? It's a 9-3. Okay.
We don't have it.
If you had a post office box, it would be a 9-3. Okay? This number is like your zip code. All right? This number is the electron's zip code. So when you see that, you have to know which zip code you have. Okay, so when you see that 1, which sublevel does the electron have? That tells you you're in the sublevel of P. So we're in the second energy level, and we're in which sublevel? P. We don't write P, we give it a number. They're called the quantum numbers, not the quantum letters. So you have to memorize this piece so that you know when Miss Wall says, oh, L equals 1, I'm talking about what sublevel? P. Okay? That's where people struggle because they don't want to memorize this piece. Okay? Say what?
Talking about when you just talking. Hey, you know what they're talking about?
What Derek talking about?
That.
Wait, which that?
All right, one at a time. Derek.
Right.
Right, I don't know what
So I just say remember 1, 2, 3.
Right. He wouldn't be confused like I am.
Most people forget that S is 0, P is 1, D is 2, and F is 3. They want to start with 1, 2, 3, 4. You got to remember S has a what? It has a 0.
What did you talk about? We went back to the principal and orbital. That's why I got confused.
These numbers right here. This is the address of the electron. Okay? So this is the first quantum number we labeled. That's the principal quantum number, which is the energy level. So that first number tells us the energy level is what? The second energy level. This number is the orbital quantum number, so that tells us what? It's the sublevel. So which sublevel is it?
It's P.
It's
But
P.
Why'd you go from 2 to 1? Why couldn't you do 2 with the sublevel 2?
It's got something to do with the next quantum number we haven't got to.
So am I just gonna confuse myself?
No, I'm getting ready to confuse all of you. But I can't fix that. Okay? All right, next quantum number. I know, Jackie.
You just go to the first one, and it goes for.
You guys are not going to have to write those numbers down. I'm just trying to explain how the numbers tie in. Okay? We're not writing any equations. The magnetic quantum number tells 2 things. Oops, let me change my color. All right?
Is this still an orbital?
Nope. This is the third one. All right? It tells number of orbitals, or. This is the only one I've given you an or. Several of them I've given you, it tells 2 things. This one, you may learn it either as it tells the number of orbitals, or it tells the number of orientation. I just told y'all we go to lunch at 1:40 today.
And nobody else got up, so. Right. You know,
I can't fix stupid. We're going at 1:40. Stay put.
What'd you write that M for? I thought she was gonna say.
I said that's or.
No,
I said
the
that
symbol.
M.
That's the symbol for magnetic. Remember, we're not going to always write these words out. This is the third. So we're going to, tomorrow when I write M equals, I need you to know that M stands for what?
Magnetic.
Magnetic. That's why I said what I did about if I gave a quiz, then you need to know these things. Because I don't want to have to constantly say what's M stand for 800 times tomorrow.
Maybe then we'll remember.
Well, I'm not going to say it. So, all right.
Oh.
It says orbitals.
It says orientations.
Yes.
What does that mean?
I was getting ready to tell you. But since you want to know now, we'll do it now.
She mixed the words.
No, oriental.
All right. I don't need a hot dog. I don't like hot dogs. Now, orientations are pictures, said Zoe wants to know. Okay? Orientations are pictures. So if you look at the notes you just took and flip back just slightly, some of you probably are on the same page. So look at the top. How many different pictures or orientations did we draw for the S sublevel?
One.
Then there is one orbital for S. All right. How many different ways did we draw the P sublevel? Then there are 3. How many different ways did we draw D?
5.
And
7.
now let's say for a second that a moment ago when we were naming for 5 sublevels, we had that question mark out there. How many different orbitals would we have if we had that one?
What?
You see a pattern. Remember when we had, just a minute ago, we had the fifth?
It'd be nine. Yeah, because it goes up by two.
7.
Oh, nine. I said seven. That's not. You ain't see, you ain't asked it.
We see that?
Yeah.
Okay.
But oh no. Oh,
we didn't hear.
Okay. Now, how many electrons can be in each orbital? If you had a reasonably good middle school experience, you would have done this. All right, how many electrons in each orbital? Any ideas?
2.
There are 2. You're paying attention, I just wrote it on the board. All right, so the S sublevel can hold how many electrons total then in the S sublevel? Okay, how many in the entire P sublevel? And in the D sublevel? And in F? All right, write that down because I'm going back to a different page.
That's like orbits or orbital.
Orbitals. Remember, orbits was Bohr. Bohr's part was wrong. It's just Schrodinger. I'm going to slide back a couple pages.
Wait.
All right. Everybody should have had time to write that.
No.
So if I cruise back to here,
Okay, 2, 6, 10, 14.
all right, if I'm an S sublevel, how many electrons did I just say could go in that picture?
2.
So I could have 2 electrons in here. All right?
It's
up to you.
We don't got color pencils.
I don't care. So if the P sublevel can have 6 electrons, how many can go in here? 2 in this orbital. How many can go here?
2 in that one.
So
And-
just 2 and
2
2
in that one.
So how many does that give me?
6.
That's how I got 6 a second ago. So when I did D and you said 10, I could put 2 here, 2 here. And so that's 2, 4, 6, 8, 10. Same thing here for 14. 2, 4, 6, 8, 10, 12, 14. Do you see how I got those numbers? Each orbital can hold how many?
2.
So a picture is a what? This is called a what though? That's an orbital. Okay? All right. Now for the part I dread.
Girl, we've been dragging this.
Now we've been doing the easy stuff.
So this is
The quiz gonna be on all of these stairs. So ask and just know.
the quiz is going to
This is quantum
name
theory.
symbols and what they tell us.
This is quantum theory.
I already told you what the quiz is on twice. If you don't remember, go back and watch the video, but I've told y'all twice.
That's why I'm gonna go get your hot dog.
I don't want a hot dog.
No, I'm gonna eat it. I mean, you was walking get the hot dog.
Now,
Right.
we have to find the values of M. Brooke, stop. So, if we have to find the values of M, we have how many sublevels? Their names are S, P, D, and F. We have to find the numbers that match the picture.
Wait, no, wait. This just we still on 3.
We're still on 3. Now, just to explain what we're getting ready to do, okay? The orbitals are what again?
Pictures.
We don't call them the orbital or the quantum pictures. We call them the quantum numbers. So we have to assign numbers to each of these pictures, right? When I wrote the address, did I draw a picture right here? I gave it a number, didn't I?
Yeah.
So I have to give the pictures numbers. So that's what we're getting ready to do on this slide, is give the pictures a number. Okay? Yes. Okay. So what was the L value? What did we just write down a minute ago? L was equal to what?
0.
L was equal to 2 or 1. What was L equal to here?
You sweet.
L was equal to,
1.
and L was equal to what? All right. Now you got to use your math skills. And remember, Miss Harvey's a math teacher, so don't get this wrong.
Is she really?
She's a math whiz.
Okay? So y'all don't want to get this wrong. All right.
Brooke, you sound like it.
Oh.
So we're going to plug 0 into this formula, right?
Yeah.
So minus 0 to positive 0 is what?
0.
Thank goodness.
Wait, which what?
Wait. 1.
Negative 0.
I took this 0, this value of L, and I
Hey,
plugged it in to that formula, right? So 0 minus 0 to positive 0 would be what?
All of these gonna be 0 because it's all gonna be positive.
That's why I was like, you using the same ones.
What if you put an S right there?
That'd be 2. Wait.
Hang on. How many pictures did S have?
1.
So I only have one number calculated because there's only how many values for M here? M equals 0. That picture is going to have a value of 0. Now, before y'all all go nuts. So here, hold on. M is equal to minus 1 to positive 1. So what are my numbers? Minus 1, 0, and positive 1. How many different numbers is this?
3.
How many different pictures? Jackie. Y'all stop imitating Jackie. So we have P, but how many pictures do we have for P?
3.
You got 3. That's why we have how many different numbers? We have 3 because there
I don't
are
understand where you got that 0 from.
3 pictures, and all 3 pictures have to have a number assigned to them.
But look, so in the first one, you added them together. In the second one, you didn't add them together.
I added them. Added what?
Negative
On the number line from negative 0 to positive 0 is just 0. There is no negative 0 and positive 0. It's just 0 on the number line. So it's 0.
On the number line from negative 1 to positive 1, it's just 2 jumps.
So the next one, 2.
Wait. Negative 1 is 0. Why did you put 0?
Yeah, do the next one.
I'm right.
He was like,
You raised it. You raised it.
It was.
Okay. So if I do the next one, all right, we're going from what to what?
2.
Negative 2 to positive 2. So we would include what numbers?
0.
Negative 2.
Yeah, Lincoln or suicide.
I'm going to lose my mind.
Are you adding because the numbers go up?
So you're not adding nothing.
I'm not adding nothing.
Yeah.
Are you adding all of those because it's 5? It was 5 pictures in the same.
I'm just simply writing down the numbers between this number and this number. So what numbers would be included in the set between negative 2 and 2?
You didn't include.
There's a lot of tension in your
There's a lot of tension in here. Y'all can't tell me the numbers between negative 2 and 2.
You
That's a middle school skill. I've been observed and losing my mind. You'll write this down. Maybe you need to come back during 4th period.
This law, you need to take a break and sit down. No, basically.
I'm going to need more blood pressure medicine.
Yeah, you can
That's not going to help my blood pressure. You know how much sodium's in those things.
You gonna be one we can calculate how much sodium is in it.
So, there are how many different pictures for the D sublevel? There are 5. So each of those pictures coordinates with each of the numbers. So this one would represent negative 2. This one would be negative 1, 0, positive 1, and positive 2. But I'm not adding any of the numbers together.
You should have said that. That probably would have cut down a lot.
I'm pretty sure I did somewhere along the line. Okay? So L equals 3. So we would have minus 3, minus 2, And those would go with all of the 7 that we've already drawn, right? So each of the 7 would have those pictures. 1, 2, 3, 4, 5, 6, 7. Get rid of that one because that's an odd. Okay? That's what those numbers stand for. Does that make sense?
Yes.
Okay.
Yeah, man.
I got it a long time ago.
All right. The last quantum number, number 4.
Oh my God, that video's gonna be funny.
What's that number? That video.
It's probably.
I'm gonna go watch it today.
All right. The spin quantum number.
That's 4. You don't ever even put the numbers no more.
Okay? It's number 4. Put a 4
Is
up
that
there.
capital N?
It's just a lowercase s. You can capitalize it if you want.
Miss Warren, you posting this video?
Yes. The spin quantum number tells the spin of the electron in an orbital. Stop worrying about it. Now,
We're not coming tomorrow.
if it's in an orbital, how many electrons did we already say could be in an orbital? 2. So, how many electrons, or how are the electrons going to spin? Do you think they're going to spin in the same direction or in opposite directions?
Opposite.
That's right. So, they're going to spin in opposite directions. Okay, they're going to spin in opposite directions. So in science, we usually refer to that as counterclockwise and clockwise. So we give it a number or a value of plus or minus 1/2. Now, it doesn't matter whether we put plus 1/2 of clockwise or minus 1/2 of counterclockwise. That's irrelevant. The part that's important is the plus 1/2 should tell you that they're what? They're opposites of each other. That's the important piece. Okay?
Why you put the 1/2?
Because that's the value we've assigned to it. I didn't do it personally. Scientists did a long time ago. What time do I have?
Time to go.
No, we got a little time to practice. See what we can do. A little time. We don't have a lot, but we got a
Wait,
little.
that's the only stuff for that.
Yeah, that's it. I told you the first and the last one were the easiest.
What?
All right. Everybody have it? Let's see what we can do.
So wait, so what if we do this to find?
Let's see what you can do.
Numbers.
We're going to use this to draw orbital notations, dot diagrams, and electron configurations, and read the periodic table. That's where we're going with it. But this is the basis for all of that. Okay? Today is just the beginning. Okay?
Well, one of your students is trying to page you.
Yeah, I know. I'm trying to pull
Juan
something
does
up.
not understand.
Juan does not understand. The spin, electrons spin in opposite directions. One goes one way, one goes the other way. That's all you got to know. There's always 2. Well, I won't say that. Some orbitals are empty. Some only have 1. But if there's 2, they spin in opposite directions. Okay? Now, the first 3 are easy questions. Okay? We should be able to do those pretty easily. Okay? Well, I hand out the homework.
No,
What?
keep it.
No. I'm getting ready to answer you questions that are very similar.
We got 3 minutes.
What?
Okay? Let's see what we can do. We have like no time. We got hung up trying to figure out
Say
how
which
to.
quantum number, we gotta say the
That stuff
name.
was hard. No, it was like it was.
No, that's an
It's, but it's an energy level.
Yeah.
Small amount.
Yes.
So when you say, quantum number, that's not it.
You can say the name or the symbol. Why do I
It's
have
hard.
not?
Hey,
You ain't pretty enough.
No, I didn't print it off. I was supposed to say no.
follow my YouTube channel. It's chemistry stuff. It's enough.
They gonna be like,
We out here on my channel. We out here learning real stuff, real life stuff, man. Subscribe to my channel, man.
Hey, get her the 300K.
That's it.
Trying to make that
Keep me doing.
I mean,
What?
no.
I need 1 million subscribers.
In the section below, what type of videos that we
All we do.
What is it?
I'm gonna be like,
We got homework practice down there.
What tells the number of orbitals? Magnetic. You can stop. What tells them? You will say, well, you know how much I enjoy
I'm
this.
saying,
What is it?
All right, what tells the number of orbitals?
magnetic.
You can say magnetic, or you could have said what?
M.
Either answer is fine. M or magnetic. All right. How many sublevels do you have if n equals 4?
4.
What are their names?
Spin, magnetic, orbital,
S.
What you talking
SPDM. Oh, wait.
Those of you who are yelling 4S, 4P, 4D, and 4F have the right answer. Okay? If there's 4, you have 4 energy levels, you have 4 sublevels. So you name them 4S, 4P, 4D, and 4F. All right, how many electrons do you have if you have a D sublevel?
3.
Anybody get that far?
14.
There's 5 pictures. How many can you have in each picture? 10.
Oh.
Okay? Any idea which one's bigger if you have a 4S or a 3D?
3D. Because it's
What tells energy level?
4S.
The 4 tells the size, not the S or the D.
Four.
The energy level. That's the rings.
Okay.
Remember, the rings tell size, right? So 4 has 4 rings, 3 only has 3 rings. 4 is a bigger energy level, so it's going to be bigger. Whole sheet for homework. All of it. They're simple questions. And they can't figure out why. That's although you should come back and physical science. So we have 250 equals 50 times A. You're like, I'm going to do. See what's going to But I did enjoy it though. They enjoyed it. I feel
We
bad.
be in here learning. We be in here learning this hard.
And you have to do like,
I know.
I know.
Okay.
Tell me something like pre-cal. What math class you take? I mean, like pre-cal? Pre-cal? You took pre-cal and you had 5 numbers on the number line.
One. This is you when you do something. Number 1, you don't count that. You go 1, 2.
What, what?
It's the video go we put on YouTube.
Oh, so I can add it right there?
Oh,
But I'll load it on the website later today.
I'll be back after school
We all want to.
with my test races and my quiz.
Come on, dog.
I'll be out to school for you.
Okay.